So dear all, we are back again. And the next topic in unit number 3, that is for fluctuating load, is fatigue failure. Okay. Now fatigue failure is generally occurs just because of the fluctuating stresses, which we have seen in the next previous lectures. That what are the fluctuating stresses? You can say the reverse cycle. You can say the fluctuating or alternative stresses. Due to this, the fatigue failure occurs. Now let's see what is fatigue. So fatigue failure is defined as time delayed fracture under cyclic loading. Okay, it's a time delayed fracture under cyclic loading conditions. So an example of parts in which fatigue failures are common, which is transmission of shaft, connecting rods, gears, vehicle suspension, ball bearings, and many more. So to understand this fatigue, take an example which we all know very much. That suppose there is a wire of diameter 2 to 3 only, and we want to cut it in two pieces. So suppose we don't have any hacksaw, any plier or anything else, we don't have anything, so we need to cut it in two pieces. So how we are going to cut it? Just see this diagram. We will apply a force from this side and one force from this side, and we will bend it first in the downward direction and then the reverse. So these reverse stresses act on it. Okay, so this continuous movement will lead to a tensile and compression stresses at this portion, and due to this, one time it will face a crack here. Before yielding only, it will generate a crack here. So that crack is nothing but your fatigue failure. Okay, so this is known as fatigue. This is a shear operation, and due to this, alternative bending and unbending the wire for few cycles give you the cut portion of a wire. Now fatigue failure mainly begins with the crack. Okay, so the region of discontinuity, just as oil holes, keyway, screw threads, is the region where it occurs. So region of irregularities in machine operation also, such as scratches on the surface, stem mark, inspection marks, and internal cracks due to defects in material like blowholes. So these regions are subject to stress concentration due to the crack. Okay, the crack spread due to the fluctuating stresses only, until the cross section of the component is so reduced that the remaining portion is subject to sudden fracture. So there are two distinct areas of fatigue failure, that is region indicating slow growth of crack and region of sudden fracture with a coarse granular appearance. So the fatigue failure depends upon a number of factors like cycles, mean stress, stress concentration, residual stresses, corrosion, and many more also. So that this makes the design of components subject to fluctuating stresses more complex. Okay, the other things which affecting a design. So fatigue failure is a criteria in design to design a component based on fatigue failure, mostly in rotating element. Now factors to be considered while designing. So these are the 7 factors which should be considered while designing a component based on fatigue failure. First, the size, that is the variation in the size. Then the holes and notches, okay, should be avoided, or stress razors should be avoided, or we should follow the stress concentration remedy methods. The proper stress deconcentration, such as fillets and notches, which I already told. The part should be protected from corrosion, so proper coating should be there. A smooth finish should be there on the outer surface, because maximum fatigue failure occurs on the surface only. The material with high fatigue strength should be used. and the residual compressive stress over the part surface increase its fatigue strength. So this is how we can avoid fatigue failure. Okay, I think you understand this part. Thank you.